Hey guys, how's it going? So today we have a nice short little lesson that I think you're going to like, central tendency in frequency and interval distributions. So the good news here is everything that you know about central tendency, finding the mean, finding the median, finding the mode, all of that is still true. Nothing's changed. What we're doing here today is just figuring out how do we handle situations like this, where we've organized our data into, for example, a frequency table. So the first half will be frequency tables. The second half will be what we call interval tables or group tables. So let's dive right in. In a frequency table, our data is listed on one side, and how often that data appears in our set is listed in the second column. So for example, if we took a pool of the number of children on a street, and we asked how many children do you have? Well, the answers are 1, 2, 3, 4, or 5. 6 families answered 1. So we put that into one row. 16 families said 2. 12 families said 3. So instead of listing out 1, 1, 1, 1, 1, 1, 2, 2, 2, 2, 2, 2, in a huge long list, we're just organized into this nice, neat little table. And it makes it very easy to do things like find out how many places we actually have. By just adding up the frequency, we get the total number of people that we ask this question to. So, given this format, how do we find the mean? Well, normally to find a mean, we add up all our values and we divide by how many values we have. We're going to do the exact same thing, but instead of going 1 plus 1 plus 1 plus 1 6 times, and then 2 plus 2 plus 2 plus 2 16 times, and so on, we're not going to do addition, we're just going to do multiplication. So I've written here, the mean is the sum of the products of the data values and their respective frequencies. So the products of the data values and their respective frequencies looks like this. So we're going to make this equal 1 appeared 6 times. So that is the product of the data value and its respective frequency. So we're going to add that to 2 appearing 16 times. Add that to 3 appearing 12 times. And so on. 4 appears 10 times. And then 5, we're going to add, appears 9 times. So this is the sum. We're adding up the products of the data values and their respective frequencies. So that's our top. That'll give us our sum just like we would if we added up every single value in our list. Now we're going to divide that by the total number of data values. And again, we don't have to count individually, we just need to add up the frequencies. So in this case, we added them all up and we get 53. So here, if you punch this into your calculator, we find that the average is 3. So the mean number of children is 3. So, even though it represented kind of differently than just a long list of values, it's more organized. Even though we have it in this format, we can still find the mean basically the same way. We have some shortcut to make it a bit quicker. So, you're asking, well, that's just one measure of central tendency. How do we handle a median? Well, it's exactly the same way. If there's an odd number of data, it's still the middle value. If there's an even number of data, it is the mean of the two middle values. But again, we're just looking at it a little differently. Instead of a long list of data, we have to decide where is the middle value in this position. So if there are 53 data points, then the middle point is going to be on the 27th the 27th value. So just go through it. This will be the 6th, the 24th. Aha! So if that's the 24th value, then the 27th value is going to be in here, so it's going to be 3 as well. So therefore, the median is 3. So far, so good. Lastly, the mode. How do we find the mode in something like this? Well, this is the easiest one. We don't have to scan the whole long list and try and see, okay, there's 4 over here, 3 over there, 2 over there. Try and see which one appears the most. The values are given for how frequently each number comes up. So which one of these, what value is the mode? Well, it's 2. 2 appears 16 times in this set. So that's all it is, the value with the highest frequency. So in this case, the mode is 2. So again, just looking at the frequency makes it very simple to see which one appears the most in a set of data. Okay, so that's all well and good for frequency tables. We said there was another type of table to organize our data. So we call this a distribution of data grouped into classes or groups, or most often they're intervals. So what these interval brackets mean, just to remind ourselves, if the bracket is facing towards the number is included in the set, it's part of this interval. If it's facing away, it means it's not included. So this is any value between 20 and 40, but not including 20. So it goes all the way up to 39.9999999 and so on. But 40 is included in the next interval, all the way up to 60 not included. So actually this goes up to 59.9999999 and so on. So in this example, we have the height of a dog. And these are in centimeters, so we get some very tall dogs towards the end. And again, we have frequency. So just instead of one number here, we have an interval. That's the difference between this and what we were calling the frequency tables. So how do we handle a situation like this? Well, the mean, as usual, we're going to want to add up all our points and divide by how many we have. Well, we don't have points here to add up. So what we do is we choose a point to represent that entire class, that entire group. And the best point to do that with is the midpoint of that class. The one right in the middle is the best representation of that group. So written here, we put the sum, meaning we're going to add them all up, the sum of the products of the midpoints of the data and their respective frequencies. So this is going to look almost exactly like the last example, but instead we're going to choose one value out of all of these intervals, so one value out of this interval, one value of that, to represent that interval. So let's look. What is the midpoint between 20 and 40? Well, that would be 30. So 30 is going to stand in for this whole group. We're going to multiply that by how often we see it. So we see 30 18 times. 30 is just representing this interval. We're finding the sum, so we're going to add that to 50 times 19. Add that to what's between 60 and 80? 70, 13 times. And I think you get the idea. 90 times 20 plus 110 times 10. So that'll give us our sum total. Again, dividing by the number of data, which is the frequency all added up. In this case, it's 80. Punch that into your calculator, and you're going to get 66.25. The unit is centimeters. So the mean height is 66.25 centimeters. Can't forget our units, because this is a real life example. Okay, so there's mean. I think you're getting the idea that it's always about the same task. The median as well, always about the same task, but you're going to see a big similarity here with what we just did. The median says, the class that contains the median is called the median class. Alright, so far so good. The middle value of the median class is our estimate of the median. So again, we don't know which numbers exactly are in here. We don't know, this number could be all 21s or it could be 25, 35, all these different values. We just know that we have numbers that appear in this class 18 times. So we need a number to stand in for it so we could do our calculations. So what do? We say that the median class, the middle class in this case, is from 60 to 80. It's for sure right in the middle with 5 classes. That's our middle class. The other way we could look at this, the more precise way I should say, is we have 80 values. So the 40th value should be our median. So we count up until we get to 40, it lands in this class, and there we go. So far it's exactly like how we used the frequency tables. So if it's in the middle class, if this is our median class, 60 to 80, then the median is the midpoint between 60 and 80, which is 70 centimeters. Finally, the mode. The class with the highest frequency is called the modal class. So we had the median class, and now the modal class contains the mode. The midpoint, doing a very similar thing. The midpoint of the modal class is our estimate of the mode. So you probably expected this. We look back at our table. Which class appears the most? Well, 20 is the biggest number. So our mode is going to be the midpoint of this interval. So between 80 and 100 is 90. So the mode is 90 centimeters. So that's all for now. See you in the next one.